Okay, so welcome back to another video. So in today's problem, we got this little design of a Venn diagram. So let's see, the left circle, it's defined with straight lines, just your standard linear equation y equals ax plus b. And the elements inside the left-hand side is that we got our xy coordinates 3, 5, 2, 2, negative 1, 7. And on the right side with the circle, it defines all the sets of parabolas y equals x squared plus cx plus d, given with our coordinates negative 2, negative 4, 2, 4, and then negative 3, negative 1. And so the question and what we're trying to solve for is the center here, known as the intersection. So what are the coordinates such that it satisfies this intersection of these two sets? So I marked this in orange, so the orange box is what we're trying to solve for. And this is just a little quick set theory problem that I think it's pretty neat, that I thought it's interesting to talk about and solve. So let's do it. So straight line, so we got straight line standard defined as y equals ax plus b. How about I actually call this set just capital L, and then on the right side we have the parabola, and so that's defined as y is equal to x squared plus cx plus d. I'll define that set as p. And so really the question we're trying to solve is, what is the intersection of L and P? Like, what are our elements of these two sets that intersect each other? So that's what we're trying to solve. So the first thing we want to do is actually want to solve for our variables a, b, c, and d. Well, not variables, the constants, such that after finding those constants, we'll be able to find our solutions, our coordinates that fits as the elements that satisfies the intersection of these two sets. How about we start with the first one, our standard linear equation y equals ax plus b. So how about I take I'll take two random coordinates out of here, and we'll solve for our variables from there. So as you see, ax is supposed to represent the slope. So how about I stick with 3, 5, and then 2, 2. Okay, so this means I pick, let's see, 3, 5, and then 2, 2. Okay, clearly 2, 2 is closer to the origin than 3, 5. So that means when you're finding the slope, it's basically m is equal to y2 minus y1 divided by x2 minus x1. So, changing y over changing x. So let's see, we'll stick this with, this is going to be x2 y2 and x1 x2, or x1 y1. So this means we'll get that this is, let's see, y2, so it's 5 minus 2, and then 3 minus 2. So therefore I get that this is 3 divided by 1, so it's equal to 3. Rather, I should put that as a, so instead of m, this is supposed to be a over here. That would have made sense that way, because that's what we're trying to solve for. So a. Okay, so a is our slope, so we just plug this back in. So y is equal to 3x plus b. So now next we have to solve what our value b is. So I'll just take a random coordinate. We'll pick the 3, 5. So solve for b. So let's see, I have 5, and then that's equal to 3 times 3 plus b. We see that this is 5. That's equal to 9, and plus b, and therefore b is equal to negative 4. Okay. So far, let me write down what we found for our straight line equation. So this is, so far we have that this is y is equal to, let's see, 3 and then negative 4. So this is 3x and then minus 4. So we solve for our straight line, the linear equation here. So now next we need to solve is our parabola. Okay. So we're going to do the same thing just like before. I'll pick two random variables, and that way we can solve for our values, constant c and d. So let's see, how about I pick negative 2, negative 4, and 2, 4. Okay, So that means we have that this is, let's see, y for this one is -4, and that's equal to, let's see, -2 squared plus c times -2 plus d. If we simplify this out, I get that this is -4, that's equal to, let's see, 4 minus 2c plus d. Okay, and then the next one, for 2, our coordinates 2, 4, so that means this is 4 is equal to 2 squared plus c times 2 and then plus d. Now we simplify this out on the right side, we get that this is 4 is equal to 4 plus 2c plus d. Okay, well, I'll keep this in red. Now, so far we have these two equations. How about I write it like this? This is 4 minus 2c plus d equals to -4. And then the other side, we get that this is 4 plus 2c plus d is equal to 4. Okay, now, in case you haven't noticed, we actually have a systems of equations, and we can solve this to find our variables. So what I'll do is I'll actually just add these two together, so that way the c's will cancel and we're left with d. So let's see, we have 4 plus 4 is 8, and -2 plus -2c plus 2c, that cancels, so 0. D plus d is equal to 2d, and -4 plus 4 is 0. Okay, so 8 is equal to, or 8 plus 2d is equal to 0. I can solve that, so we get 2d is equal to -8, and so we get that d is equal to -4. Okay, now we have that. So now I'll just stick back -4 in there. I'll just put the -4 back here. So let's see, we have 4 minus 2c, then plus -4 equals -4. But we see that the 4 plus -4 cancels, and then we're left with -2c is equal to -4. So therefore we have that c is equal to just 2. Okay. And now with that, we have solved for our values to put in our parabola equation. So let's see, we have that y is equal to, let's see, x squared plus cx. So instead this is plus 2x, and then plus d, which is -4, so -4 over here. Nice. So we solved for our values of a, b, c, d. Now, next thing, the big thing we want to solve is we want to find what are elements for this intersection that satisfy the two sets. So how do we do this? Well, because we already solved for our values a, b, c, d, and then we know what the value is of the equations for both these two, both the line and the parabola. Now, the definition of intersection basically means you have two sets. When you take the intersection of those two sets, you're trying to find what are the common, what elements do they have in common. So what this means is that what I'll do is, in order to do this, I'll actually just set these two equations equal to each other. So that means this is 3x minus 4, and we set that equal to x squared plus 2x minus 4. And do some algebra here that's not too hard to show. Let's see, I'll subtract a, I'll subtract a 3 here. I'll subtract 3x and then add a 4 to both sides. Let's see, so I got x squared. Let's see, subtract 3x, so that's -x, and then add a 4. So that means I'll get that this is equal to, let's see, that's 0, so that's equal to 0. Okay, and so therefore we get that, I'll factor out x, and then we get an x minus 1, okay, equal to 0. And so therefore I get that x is equal to 0 and x is equal to 1. Okay, and now that we found our x values, now let's plug back into our equation to get those coordinates. So let's see, if I plug, x equals 0, then that means, let's see, 0, that means if I plug 0 for here, that means this is 0 minus 4, so it's 0, -4. And if I plug 0 over here, that means 0, 0, and then -4, so I get the same thing here. So now I'll plug x is equal to 1. So let's see, 1, and 3x, 3 times 1 is 3, minus 4 is negative 1. Okay, now if I plug x equal 1 here, so let's see, 1 squared is 1, plus 2, that's 3, then minus 4, negative 1. Okay, so we already found our two coordinates. When we find that the two solutions, x equals 0, 1, that they equal each other, when we plug x equals those values back, then we can solve for our y value, which we have is over here. So therefore, we already answered the question. Therefore, the intersection of both sets, the straight line, I denote that as L, and then the intersection with P, write that again, L intersect P, which that's the parabola. Therefore, our answer to that is we have two elements, two coordinates in particular, 0, negative 4, and then 1, negative 1. And there we have it. Not underlined, but answer is in this big black box over here. All right. Now, that's pretty cool if you ask me.